Hi, I'm the Huntsman, and welcome to episode 1 of Electronics Basics. So, today we're going to be learning about voltage, current, and resistance. Now, they're all very, very important to electronic circuits. For example, voltage and current are really what powers your whatever you're trying to power, whatever you're trying to do. They really operate the whole thing. So let's just take this circuit, for example, right? We have our battery here, we have a switch here, we have a resistor and an LED, and then we have a coil. Doesn't really matter. Now what we do is if we flick this switch, current will pass through there. I'll explain this in a couple episodes. We'll be talking about circuits in series and parallel. That's a whole different topic. So basically what happens is if current passes downwards here, it would go to the LED. But what is the problem is LEDs draw a lot of current, and the more current they draw, the more hot they get, and eventually if they draw in too much, they actually burn out and explode. So that's really, really bad for what you're trying to do. So really what we need to do here is we need a resistor. So if we place a resistor in place, we now know that this LED will turn on. So really, resistance is there to keep your circuit safe and really not blow everything up. They really regulate current. Now, you're probably wondering, okay, so current is what's powering the stuff. What's voltage? I thought voltage powered it. Now, what voltage does is, yes, it does partially power it. The way I like thinking of voltage is like water pressure. So basically you'd have the water pressure, right, in a hose. And the more pressure you apply, the more water comes out faster. But in the long run, you do not get more water. So, for example, in this little picture here, right, this little thing I drew, if we increase water pressure to, say, 60 psi, and we let water pass through, if we measure this amount of this for, say, 2 seconds, we'll see more water pass than, say, if we put it at 40 psi, because there would be more water. Water in this case would be the current, and the pressure in this case would be the voltage. So if we have more voltage, for a shorter period of time here, we'd have more current. Now, you're probably wondering, okay, so what does all this mean? Really, it just means you need current to power your stuff. And what current is measured in is amps. And similar to this, amps is the amount of electricity, the amount of electrons passing through a certain point for a specific amount of time. So you probably have heard for some batteries it says 2,000 milliamp hours. That really means you have 2 amps per hour. So every hour you will release 2 amps for that hour. So that's pretty much voltage and current. They're pretty simple. They're really there just to power your objects. That's pretty much all there is to voltage and current. But resistance is a little bit more complicated. Now you see, you kind of need to know a little bit of chemistry to know this. So different metals and different materials are different conductors. You have really, really good conductors and you have really, really bad conductors. Now, good conductors, an example would be silver, which is actually the best conductor we have known to man, really. And one of the worst conductors we know, and you've probably seen these in cartoons or stuff, is rubber. Now, rubber will not conduct electricity. In fact, it will burn similar to wood. But metal, which is really, really great, is it takes in electricity. And it takes it all the way in and passes it through to the other side. Now, if we want resistance, we'll always go to a resistor. Now, this is a resistor. Let's see if we can focus. And how this works is this little ceramic part in the middle does not conduct that much amount of electricity, so it doesn't let that much pass. In fact, it takes the current and it heats up the ceramic part, but lets other current go through the metal. You basically the higher amount of ohms you want, which are measured in the omega sign or ohms. Volts are measured in V or volts, and amps, like amps, are measured in A. And really, that's all there is to voltage, current, and resistance. Now, to demonstrate these points, I have a couple circuits that I'd like to show you, so I'll get right back to those. So here's our first circuit. As you can see, we have a pretty simple circuit, just a 9-volt battery powering an LED, and it lights up well. Now, let's see what happens when we add in resistors. And as you can see, if we add in 2 resistors of different ohms, we can see that the LED doesn't even turn on because all the current is going to the ceramic caps. Now, what happens if we take out the resistors and put in another battery? What if we put in a 3-volt battery? As you can see, with the 3-volt battery plugged in with the LED in there, this no longer turns it on either because there's not enough electricity. Now, to note this, you should note this. With this 9-volt, this 9-volt is actually too much electricity for this LED. Without any resistors, it's extremely dangerous and could actually burn out the resistor. Lucky in my case, this resistor did not burn, but it no longer works with 3-volt batteries. It only works with 9 volts, and specifically this amount of voltage. Now you see what these resistors did, is they actually decreased the current coming from the battery, so the LED could no longer turn on. So in conclusion, we can see that voltage, current, and resistance are some of, if not the most important parts of circuitry. Thank you for watching the first episode of Electronics Basics. I really hope you enjoyed it, and tune into next episode where we discuss Ohm's law, Kirchhoff's current law, parallel circuits, and circuits in series. Seriously, thank you for watching.